In this lecture, let us talk about the conditional mean and conditional variance of bivariate random variable. This is a very simple concept. So let us talk about discrete bivariate random variable case. If x and y is a discrete bivariate random variable with its joint probability mass function p sub x y, then the conditional mean or the conditional expected value of y given x is equal to some small number x. So the conditional expected value of y is defined as the expected value of y given x is equal to the product of some number y into the conditional PMF of y. So here we are talking about the discrete random variable, so we will take the summation. In similar fashion, we can find out the expected value of random variable y, its mean, or the expected value, conditional expected value. So for this case, we will replace this y with x, random variable x, and we have a given y. So in this formula, in this product, we will replace y with x, and we will take the conditional PMF of x given y. So then we will take its summation. Now the conditional variance of random variable y given x is defined as the variance of y given x. So here we will take the expected value of, we will take some random variable y minus the expected value of random variable y with the whole square given x. So this can be reduced as variance of y given x is equal to expected value of y square given x minus expected value of y given x whole square. If we want to find the variance of the conditional variance of random variable x, now what we will do, we will replace here y will replaced with x and x will replaced with y. In this case, we have given y. Now here I will replace the y with x, here x will replace with y, and so on. Now let us talk about the continuous bivariate random variable case. So if we have a given x, we have a two random variable x, y, which is a continuous bivariate random variable with its joint Pdf, probability distribution function. Now in continuous case, we take into account the probability density function. The conditional mean of y given x here would be the expected value of y given x. We will take the product of y with the conditional Pdf of y given x. Now think about the conditional Pdf. Keep in mind that how we find the conditional Pdf or conditional PMF. What we'll do, we take the joint Pdf of random variable x and y, and we divide it with the conditional with the marginal Pdf, then we get the conditional Pdf of random variable y. So in this case, what we will do, here we have given the conditional Pdf of random variable y. How we will find this? We will take the joint Pdf of x and y, and we will divide it the marginal Pdf of x. So here the conditional Pdf of y will take the product, its product with y, and it is a continuous case, so therefore we will integrate it from minus infinity to infinity. So if we want to find the conditional expected value of x given y, then we will replace here y with x, variable x, and similarly we will replace the conditional PDF of y with the conditional PDF of x given y. Now the conditional variance of random variable y given x is defined as the variance of y given x is equal to the expected value of y minus conditional mean of y whole square given x. So it is a continuous case, therefore we'll take the product of y minus conditional mean of y into the conditional PDF of y given x, then we will integrate from minus infinity to infinity. It can be reduced as the expected value of y square given x minus expected value of y given x whole square. Further, you should keep in mind that conditional mean of y given x is the function of random variable x. In similar fashion, if you have given the conditional mean of random variable x given y, then it would be the function of y. Now let us move to an example. Here for x and y, we have two random variable x and y, so their joint probability mass function is given below in the table. We have to find the expected value of y given x is equal to 2. So now first we have to find the conditional probability mass function. For this purpose, the conditional probability of y given x is equal to 2, which is equal to 1 over 4 when y is equal to 1. Keep in mind our previous discussion where we have discussed the conditional probability mass function. So in this table, when we have given here, this column shows the marginal probability mass function of random variable x. Here is the marginal PMF of random variable y. So what we'll do here, so when y is equal to 1, we have given x is equal to 2. We will take into account this row. When x is equal to when y is equal to 1, so its conditional PMF would be what we will take. We will take the joint PMF of x and y. Here the joint PMF of x and y is equal to 0.1. When x is equal to x is equal to 2 and y is equal to 1. So it is 0.1. What we will do, as already I have described, I will divide the joint PMF with the marginal PMF of x. So when I will divide 0.1 with 0.4, it is equal to 1 over 4. Similarly, for y is equal to 2, I have the joint PMF as 0.1. So I will divide it with the marginal probability mass function of x. So I will get 1 over 4. For this case, when y is equal to 3, the joint PMF of x and y is 0.2. I will divide it with the marginal probability mass function of x. I will get 1/2 when y is equal to 3. So these values are achieved by dividing the joint PMF by the marginal probability mass. Therefore, the expected value of y given x is equal to 2, I will take the summation y when y is equal to 1 to 3, then take the product of y with the conditional probability mass function of y given x is equal to 2. So when I will open this summation, what I will get when y is equal to 1, its conditional probability mass function is 1 over 4. When y is equal to 2, its PMF is 1 over 4. Similarly, I will add when y is equal to 3, its PMF is 1 over 2. So by adding these expression, the conditional expected value of y is 9 over 4. Now let us move to another example. Consider a bivariate random variable with given probability mass function as the PMF of y given x is equal to 2x plus y divided by 4x plus 3, as y is equal to 1 or 2. Similarly, the random variable x has values 1 and 2. So we have to compute the conditional mean and conditional variance of y given x is equal to 2. First, first we will find the conditional probability mass function of y given x. So here the conditional PMF of y given x is equal to which is given here 2x plus 5 divided by 4x plus 3. So the condition is that x is equal to 2. For this case, I will incorporate x is equal to 2. So this expression will reduce to 4 plus y divided by 11. Now I have to find the conditional mean and conditional variance of y given x is equal to 2. So here the conditional mean mean of y given x is equal to 2. What I will do, I will take the summation. I will take the summation of the product of y with the conditional PMF of y given x is equal to 2. So I will incorporate here the conditional PMF of y which we have already calculated. I will take the product with y. So when I will use the summation. So the y is equal to 1 and 2, so range from 1 to 2. So when y is equal to 1, I will incorporate the value of y is equal to 1 here and here. So it will be equal to 5 by 11 plus when y is equal to 2, I will incorporate y is equal to 2 in this expression. So by adding these two terms, I will get the expected value of y given x is equal to 2, which is equal to 17 by 11. Next, move to the variance of y given x is equal to 2. So in this case, we have already derived this expression, the expected value of y minus the expected value of y minus the conditional mean of y whole square. So when I will take the expected value, I will expand this term. I will incorporate y is equal to 1 because y is ranging from 1 to 2. So when I will incorporate the value of y, so there would be 2 terms. By adding these terms, the variance of y given x is equal to 2, which is equal to 0.248. Now move to another example. So in this example, bivariate random variable x, y, whose PDF is given below. We have to compute the conditional mean of y given x and the conditional mean of x given y, and also compute their corresponding conditional variance. So in first case, the conditional Pdf of y given x is equal to 1 over x. The limits are given here. X is greater than 0 and less than 1, for y which is less than or equal to x and less than 1. Similarly, the Pdf, conditional Pdf of x given y is equal to 1 over 1 minus y with given limits. Now first let us find the conditional mean of y given x is equal to small x. So for this purpose, we know the formula for the conditional expected value of y given x. So what we will do, we'll multiply y with the conditional Pdf of y, and then we will integrate it from minus infinity to infinity along variable y. So here we have given the conditional Pdf of y, so which is equal to 1 over x. We will incorporate in this formula. So the product would be equal to y over x into dy. So now we will integrate it from 0 to x. So by integrating this so this will be equal to y over x. So when we will integrate it, so we will get the expression y square over 2x. By incorporating the limits from 0 to x, so we will get expression x by 2. So as I already explained that the conditional mean, the expected value of y given x, is the function of x. Now the expected value of x given y would be the function of y. Here the limits are x is greater than 0 and less than 1. Similarly, we can find the conditional mean of x given y. So here the conditional mean of x given y, in similar fashion we will integrate from minus infinity to infinity the product of x with the conditional Pdf of x. So we know that the conditional Pdf of x is given for given y is equal to 1 over 1 minus y. So we will take the product of x with the Pdf, conditional Pdf of x. So the product is equal to x over 1 minus y. Now I will integrate it from y to 1. So by integrating this, because the upper limit is 1 here, so by integrating this expression we will get 1 plus y divided by 2. So this is the expected conditional mean of x. So it is the function of y. As I already explained, the expected mean of x given y is the function of y. Similarly, the expected mean of y given x is the function of x. Now let us talk about the conditional variance of y given x. So in this formula, we already know the formula. Now we take the expected value of y minus the mean of y with square. So this would be equal to integration from minus infinity to infinity, y minus x divided by 2. X by 2 is the expected mean of y here. So with its square, I will multiply it with the conditional Pdf of y given x. So by integrating this, I will get by integrating this expression and incorporating the limits from 0 to x, so I will get the variance of y given x. So it is also the function of x. So this expression is equal to x squared divided by 12. Now let us talk about the variance of x given y. So by incorporating here we have incorporated the mean of x given y. So x minus mean of x given y with square, then we will take the product with the conditional Pdf of x given y. We will integrate it from minus infinity to infinity, so we will get this expression by taking the limits from y to 1. The final expression is 1 minus y whole square divided by 12. This is the variance of x given y. So when this is the function of y, as already we have explained. That's it.